Welcome to FHIR Shorthand. I'm your host, Melinda Stewart from HL7. Our moderator for this session on HUVA is Brian Caney. I'd like to introduce our speakers for today, Chris Moesel and Mark Kramer from MITRE. Chris, I'll turn it over to you.
Great, thank you very much. So my name is Chris Moesel. I am from the MITRE Corporation, and I'd like to first give a short shout out to Mark Kramer and Nick Frieder, who helped me with designing this exercise as well as the solution. And we are all from the MITRE Corporation. MITRE does some pretty cool stuff, so if you haven't looked into any of those things on the right-hand side, you should. They're fun. We're just going to keep on moving, however. So we want to start off by just briefly introducing FHIR Shorthand. Hopefully most of you were able to go to the tutorial and you already learned about this, but basically FHIR Shorthand is a domain-specific language. It's designed to help you profile in FHIR as well as define other implementation guide artifacts like value sets, code systems, etc. It's very young, but it is actually already balloted, and it was balloted in May, and we're currently going through those ballots. There will be some changes, but by and all, it was a successful ballot. Now, just to get some terminology out of the way, when we talk about FHIR Shorthand, we're talking about the language specification, what you use to actually do the profiling. When we talk about Sushi, we're talking about the reference implementation compiler. So this is what takes the FHIR Shorthand and converts it into other artifacts in the implementation guide. That's about all we're going to do because we have a lot of content to cover. So we're going to jump right into the exercise now. And we are going to build with FHIR. So FHIR is something we call FHIR Shorthand. The F is for FHIR, the SH for shorthand. So FHIR, let's build with FHIR. So a brief overview of the exercise. Our exercise was to recreate US core patient profile, mostly. Now, US core patient profile was originally written using the spreadsheet method of profiling. If you would like more information about all the different ways that you can do profiling besides just FHIR Shorthand, we briefly go over those in the tutorial, so you can check out that recording to find out more. For this exercise, we're going to be looking at the high-level metadata, the value set bindings, the must support flags, extensions, cardinality constraints, and more. So again, the goal is to take what we see on the left-hand side, which is the actual published US core patient profile, and figure out how would we create something like this using FHIR Shorthand, which is on the right-hand side. So we designed the build exercise in 12 simple steps, and we're going to be going through all of those. Hopefully at this point you had a chance to actually try the exercise. There isn't time in this 40-minute session to actually do the exercise, so we're just going to be going over the solution one step at a time. If you would like the instructions, there is a URL at the bottom, but there's also instructions linked in, I think, in the tutorial from Monday, so you could check that out. I will pause at a few steps to ask Brian if there are any questions that would be good to cover at that time. But for now, we're just going to keep plowing through. And we're going to actually skip steps 1 and 2, which are to install the software and review the FHIR Shorthand basics. And we're going to go right into step 3. Does anybody else see those yellow marks on my screen? I do not know what those are. But anyway, so we created a starter project for FHIR Shorthand exercise. And this includes just those files and the file structure that you need to get started. Most of it is boilerplate, but we do have a config YAML file, which we added some data in there that would be useful for you, not to have to come up with on your own, but would get you on a start. And then we also have the patient.fish file, which is empty, but that's where you put in your definitions. So yeah, those lines are annoying. Let me see if I can figure out. Nope, I don't know how those lines ended up there. We'll keep on going.
Yes, we see it too, but I don't know. They just appeared.
Yeah, okay. It looks like somebody annotated my screen. Did I annotate my screen? Can I erase them? Ah, okay, perfect. Now, so this is the configuration YAML file. This provides the configuration that Sushi will use as it does its thing, as well as provides some data that will go into the implementation guide resource for your implementation guide. If you're familiar with the implementation guide resource, you'll notice that many of these fields parallel what you see in that resource. I'll just draw your attention to a couple of things in this file. One is that we have a publisher and jurisdiction defined here in the configuration. And then at the bottom of the file, we have some parameters. These parameters are actually passed through to the IG Publisher. And the ones that we've enabled are apply contact, apply jurisdiction, and apply publisher. What this does for us is it will take that publisher, the publisher contact information, and the jurisdiction, and it will apply it to every profile that we define in US Core IG, as well as value sets and things like that. That way, we do not have to go through and define those on every profile individually. You'll also see a menu item, and this allows us to actually define the top level menu. And this is a very simple key value mechanism, so you can add other entries to the menu as well, but here we've just included 2. So that is step 3. Step 4 is to review the US Core patient profile. So now that we've downloaded the starter project, let's look at what we're actually going to be trying to build. On the left-hand side here, we have the rendering of the US Core patient profile that you get if you go to the profile in your web browser. And we can see here that there's a number of key features here. This is just showing what's different in the US Core profile of patient versus the base definition of patient. So during this exercise, we'll be doing things like setting cardinalities and flags, as you see here. We'll be creating a value set and binding it to address.state. We'll be creating an extension and associating it with this profile. And we will be displaying some short descriptions of a few fields. Now, this is the human-readable view of the profile. But on this slide, I'm showing you this is the formal view of some of those aspects of the profile. So I've just called out those bits that I highlighted in the previous slide. This is what they look like in the formal structure definition JSON. I've removed some properties just to make sure everything fits, but this is what the IG Publisher looks at and what integrators will look at when they're trying to understand what your profiles are. Now, if you didn't have FHIR Shorthand or Forge or some of these other things, you'd be stuck writing this stuff yourself, which can get pretty complex when you start talking about trying to express a lot of constraints. Structure definition files can be literally thousands of lines long, which is why we're glad we have FHIR Shorthand. So the first thing that we are going to do as we try to rebuild this US Core patient profile is just the high-level metadata. So in the exercise, we provided a table that showed this metadata and said, how would we represent this using FHIR Shorthand to create a profile? And the answer actually was in the FHIR specification. If you looked at it in the FHIR Shorthand specification, we actually used this exact example. So we made it really easy for you. But essentially, you'll see here that in FHIR Shorthand, we express high-level metadata using key value pairs. And these key value pairs actually correspond really closely to the table that we gave you in the exercise. But it's pretty simple, and we'll see this pattern throughout the exercise as we define other things as well. So let's see what we've done. We haven't done anything too interesting here, but we do want to check our work. And so we're going to go on to step 6, and then after step 6, I'll take a pause, see if there's any questions. But we want to run Sushi and build our IG. So again, Sushi is a special tool that we've built that can actually translate FHIR Shorthand into the formal FHIR structure definitions and other resources. It's actually an acronym for Sushi Unshortens Shorthand Inputs. And the way that we structured the exercise, You only need to run Sushi without any arguments. It uses all the default parameters, and then magic happens. And if everything went well, if the gods are in your favor, then you will get a green box that says great, and it tells you exactly what it built, and it includes even a nice little fun fish pun to entertain you. Now, if you made a mistake, if there was an error, this box will be red, and you'll also get a fish pun, but it might be a little bit more accusatory or insulting. And for that, we apologize. But if you fix your FHIR shorthand, it'll turn green, and it's all good. Oh, we just got some more drawing. Okay, so now we're going to go on to the next slide. And we can see once we run Sushi, it's actually generated some additional files. Now, Sushi is generating files in the structure that the IG Publisher expects. It's also generating some of the specific files that IG Publisher expects, things like IGINI, an implementation guide resource, a menu XML, and then at the bottom we can see the actual JSON structure definition for what we just defined using FHIR shorthand. So once we actually have Sushi generating all of the data that we need to run the HL7 IG Publisher, we can run the IG Publisher. And there's two scripts to help us with that. There's an update publisher, which will make sure that we have the freshest version of the IG Publisher. And then there's a gen once script, which will actually generate using the publisher with some preset arguments. Now you can see here, this is a deeper form of magic that Graham Grieve has become quite good at. And if everything goes in your favor there, then you will get a message, something like you see at the bottom of the screen. And everybody will be happy. And when you look at your IG, you'll actually see some pages. On the top left, you'll see a home page. On the bottom left, you can see the artifacts page that gets generated, and you can see that there's a US core patient profile listed there. And then on the right-hand side, we actually have the US core patient profile that we just created. Now that US core patient profile isn't very interesting. We haven't actually defined any constraints or anything like that, but this just shows us that our overall workflow is working. So Brian, do we have any questions that would be good to answer at this time? I'm going to try to delete these annotations again.
And unmute myself. Shit.
Nope, you're unmuted.
Okay, it's unmuted now. Sorry about that. I'm assuming this is not being recorded. Just kidding. I know it is. Yeah, there's a couple more advanced questions, so I don't know if you want to hold off on those. One is about operation definitions and search parameters.
Okay, yeah, we'll hold off on those.
Okay, and then just some on the tooling. Do you know if there's any plans for plugins for JetBrains or any of other editors outside of Visual Code?
Sure. So right now we've focused on Visual Studio Code. We've talked about maybe looking at something like Notepad++ because we know that's popular in the FHIR community, but we don't have any explicit plans right now. But certainly anybody who wants to create such a thing and has the skills to do so, we'd love to see the community embark on that. All right, well, I'm going to keep on going again because we have a lot of content to cover. And so the next step, and I just found two more annotations that need to be erased. Okay, the next step is step 7, add cardinality constraints and must support flags. So this is when stuff gets real. So when we're looking at the patient profile, we can see there's two columns there, the flags column and the card column. The flags column is where we have our must support flags, as well as other flags, but for this exercise, we're just worrying about must support. And then the cardinality column is where we specify our cardinality constraints. So this is what we are going to attempt to recreate using FHIR Shorthand in step 7. So here on the right-hand side, we can see the FHIR shorthand that corresponds to what we see on the left-hand side. For now, we're ignoring the extensions. But if you look at the right-hand side, you can see that there's actually a pretty tight correlation between what we see in the differential view and what we have in the FHIR shorthand. We've removed some of the fields in the FHIR shorthand definition just to make sure everything fits on the page. We do that throughout this exercise presentation, but just know we're always going to show you the fields that are relevant for what we're talking about now, and we'll only try to remove fields that we've already seen previously. So in this case, on the right-hand side, we can see we have a number of what we call rules. Each rule starts with an asterisk or a star, and then has a path. And the path corresponds to the name of the element that we see in the FHIR profile. And after that, we have our cardinality and then optional must support flags. So we can basically replicate everything we see on the left-hand side in the blue and red boxes using the FHIR shorthand on the right-hand side. You'll notice that there are some cardinalities that appear on the left-hand side that we don't have in the FHIR shorthand. That is because in this view of US core patient profile, it is actually showing some cardinalities that didn't change at all. Some of those cardinalities are exactly the same as in the base patient resource. So in the FHIR shorthand, we chose to only note those cardinalities that are actually different. So that's why you see that difference there. One other thing to note for power users is that for the must support flags, there is another way that you can do it, which is to actually list all of the fields that you want to make must support, and then just say must support once. So you would say, you know, identifier, comma, identifier system, comma, identifier value, comma, must support. And that's how you can do multiple must supports in one rule. But we kind of like the way that it's laid out here, so that's the way I chose to show it. So now that we've done this, we could run it through Sushi in the IG Publisher, and we would end up with a profile that looks like this. And we can see that we're already getting closer to what we are looking for with the US core patient profile. So we can move on to the next step. Oh, I forgot to say earlier on, I'm sorry, but hopefully you've noticed at the bottom of these slides here, occasionally Shorty the shorthand fish shows up and provides you an interesting tidbit or fact about fish. We just wanted to put that there to make sure that you learned something during this exercise, even if it's just about real actual fish. But hopefully you've been learning that along the way as well. So step 8 is to create and bind US states value set. So we told people that they should go through at least step 7 to get a basic feel for what FHIR shorthand is. And so if you got that far, congratulations, nice job, you're awesome. Now, if you were particularly brave or had extra time, then you kept on going. And that's where we are now. We're at step 8, which is the more advanced step. And this is where we're going to start looking at a value set. So in step 8, what we want to do is we want to bind the USPS 2-letter alphabetic codes value set to address.state. So this is basically just saying an address must have a state that is actually a US state or territory. So the way we need to do this is by first creating a value set. So if we look in US Core at the 2-letter alphabetic codes value set, it'll look like what we see on the left-hand side here. Now we can look at this and we can actually pull out a lot of the data that we need when we create the fish. For one, we can get the ID from the URL. We can get the name and the description from the table there. We can get the title from the header and the page. And then at the bottom, we actually have a list of codes, and we can see that they're from the code system, www.usps.com. So all of that data is there on the page if you know where to find it. This isn't always the case. In some cases, some of the metadata you can only find by looking at the JSON definition itself. But of course, if you're creating a profile from scratch, then you just get to make up all this stuff anyway. So that's fine. But in our case, we had it here nicely laid out in the value set. So we can use that. And what we're trying to define is essentially a value set with this metadata that we see at the top of the screen. And this small set of states, we didn't want you to have to do all 50 plus states and territories. So we decided you could just do the best ones, the New England states. So on the bottom, you can see that we have defined our value set. And you'll see the first thing we did was actually create an alias. So an alias is a way that we can take a URL that we know we're going to be using a lot throughout the implementation guide, and we can give it a shorter name and then just reference it by that name wherever we need it. In this case, we know that every time we are talking about a code from the USPS value set, we're going to need to use that URL. So we want to create an alias so at least we can just reference USPS instead of that whole URL. Below the alias, we see the value set definition. You'll see a very familiar sort of format here where we have key value pairs for the high-level metadata. And then below we have rules, and those rules are still delimited by asterisks, but in this case, each rule is a code, and that's using the FHIR Shorthand code format, which is the code system goes first, and then you have a pound or a hash sign, then you have the code, and then you have the display in quotes. And we just list out all the codes that we want in this value set. Now, there are ways to do more advanced value sets that use intentional rules and things like that. But for this case, it was actually just an enumeration of codes. So once you've created that, you then need to actually bind it to the address state. So we have the value set, now we're associating it to the profile. And the way you do that is using the from keyword. So you can see I've highlighted the name that shows this binding in the FHIR shorthand. We're saying the address state must come from the USPS two-letter alphabetic codes. And we're using an extensible binding strength there. Now, binding strengths are something that's defined by FHIR. FHIR shorthand gives you access to those binding strengths, but since it's defined by FHIR, I'm not really going to go into the details of what those mean here, but you can look it up on your own. It's fun stuff. So once we've done this, we can run Sushi and the IG Publisher again, and what you would see is on the left-hand side, we have our USPS two-letter alphabetic codes value set, and on the right-hand side, we have our US core patient profile. And it may be really small, but hopefully you can see that the address state does have that binding there. One other thing that you may have noticed is that on the left-hand side, the expansion says no expansion for this value set, not supported by publication tooling. That's okay. You haven't done anything wrong. That's just saying that the HL7 publication tooling doesn't really understand the USPS code system, doesn't know what to do with it, so it couldn't actually use it to generate a more formal table of codes. But your value set is fine. So I'll take another pause. Brian, do we have any questions that are relevant to the previous few steps that we should cover now? Okay, either we don't or Brian lost the mute button again.
No, I got it back. Sorry about that. It's a little slow in the uptake. There's a couple here I think that could be relevant. There's one question about does the alias declaration always have to be at the top of the file?
That's a good question. No. So I like to put it at the top of the file as a convention. Some people like to put it right before the section of FHIR shorthand that will use the alias most often. Some people like to create a separate file that contains all of the aliases in their implementation guide. Aliases are global within the FHIR shorthand project or the fish tank. So you can define the alias once in just a single file, and then you can use it in other files throughout the fish tank. So where you define it is completely up to you. It's stylistic.
And a second question, if we have time, around value sets. Is there any syntax for other value set include mechanisms such as filters, inclusions of other value sets or whole code systems, or do we need to escape for that?
Yes, there is a syntax for doing that, and it follows pretty closely the actual way that value sets are defined in the compose rules. You can check out the FHIR Shorthand specification for more information about that. And actually, if you download the solution set, and we have a link to that at the end of this slide deck, if you download the solution set, some of the advanced solutions also show more advanced value set syntaxes.
Great, that's it for now.
Okay, great. Looks like we have 12 minutes to go, so I think we can do this. So the next step is step 9, create the birth sex extension. So extensions are cool, right? I mean, this is, you haven't done FHIR if you haven't done an extension. No offense to anybody who hasn't done an extension, but extensions are very important. And so we can see that the US Core patient profile uses several extensions. We're going to use the simplest one for this exercise, and that is the US Core birth sex extension. Now, if we look in the US Core implementation guide at the birth sex extension, we'll find a page that looks like this. This contains some of the metadata we need, the title and the ID. Some of the other metadata, actually, you have to look in the JSON for, but in the exercise, I provided a table that has all the metadata you would need to create this birth sex extension. At the bottom, you can see the value code constraint. There's a few things that are happening here. So first of all, this is a simple extension, which means it just has a single value. It's not complex. It doesn't have multiple different values you'd want to associate, but it has a single value, so it's a simple extension. Now, extensions, the base extension has what's called a value choice. There's a field called value X, and it says a value for an extension can be a string or a code or a quantity or an address. It gives a whole list of different things that the value for an extension can be. But in this extension, US Core wanted to say we only allow the value to be a code, and furthermore, that code must be from the birth sex value set. So in order to actually do this in FHIR Shorthand, we're going to need to create that birth sex value set, and we're going to need to create the extension that has the simple value. So we can see on the right-hand side, we have our FHIR Shorthand. Some things you've seen before. We define a few more aliases, gender and null. Those are for code systems that are used in the birth sex value set. We then enumerate a few codes in the birth sex value set. It's actually a really small value set, and it's not doing anything different than what we've already seen before, so I won't go over that in detail. But then we have the extension at the bottom. And again, we see those metadata keys, much like we saw with profile and value set. We're reusing them again for extension, nice and consistent, hopefully. But then we run into a few new things here at the bottom. One is that first rule, value X only code. So this is called an only rule. We use the only rule to take a choice of multiple items and constrain it down to a choice of fewer items, or even say it must be a single type of item. So in this case, we're saying, although value X allows 30 some odd different kinds of values, say, I just made that number up, I don't know. But it includes a lot of values. We're saying in this extension, only allow it to be a code. And then we say in the next rule, furthermore, that code should be from the birth sex value set. Now you'll notice that we call it value code instead of value X at that point. That is a convention for how we speak about a specific choice in a choice. So that actually mirrors how FHIR does it in the JSON serialization. So it may be familiar to some of you, but that's how we speak about a specific value type. And then you'll also notice that the value set from rule doesn't have a value set binding. When we don't include a value set binding, it will default to required. And in this case, that's actually exactly what we're looking for. So once we've created our birth sex value set, we've created our birth sex extension, we can run the Sushi IG Publisher. We'll see the birth sex value set here on the left-hand side. on the right-hand side, we can see the extension. It is basically what we expect it to be. So we're in good shape. We're doing awesome. We're ready for the next step, step 10. We've made it into the double digits now, or if you are a fan of Apple, I guess this is step X. So add the birth sex extension to the profile. So again, looking at our US Core profile, we have the US Core birth sex extension there. We have the extension, we just need to associate it with the profile. So in this case, we're using what's called a contains rule. Now, the word contains makes sense if you understand that extension has multiple cardinality. So extension is actually more like a list or a set, or computer scientists might call it an array. Okay, so extension can have multiple things in it. And so the contains rule says that in that list of multiple things, there should be a US Core birth sex extension. And US Core birth sex extension is actually the name of the extension that we created. So we're referencing it by its name. But then we say, in the context of this profile, we want to actually call that birth sex extension birth sex. So that gives it a local name within the context of the profile that can be used when we try to reference elements within it by path. And then after that, we say, okay, well, actually, we can allow 0 or 1, so it's optional. But if you have one, please only have one, don't have more than one. And this is must support. So that is how we can include the extension in the profile. Now, we didn't go over slicing at all in this exercise, but if you look into slicing on your own, you'll see that this is essentially the same syntax as we use for slicing. And that is because if you look behind the covers, the extension is actually really being sliced. So we're really actually, this is a special case of slicing that's happening here. So once we've done that, we can render our profile again, and we can see now we have this nice US Core birth sex extension. All right, so moving on, we're at the 5 minutes left mark, but we're really close. Step 11 is to add short descriptions to the profile. So you may have noticed when we were looking at the profile that there were a few short descriptions there and wondered, where did those come from? Well, that's what we're going to get at next. Now, this is one of those things that in one way it's simple. The syntax is pretty simple and short. On the other hand, it's a little bit of a different, conceptually different than what we've looked at before. And that is because what we're doing here is we're talking about metadata of an element itself. So in this case, we're saying the identifier value has some special metadata associated with it. And in this case, it's the short, which is just the description that we want to display when people look at the documentation for this. So in FHIR Shorthand, whenever we want to do something like this, we start by identifying the path of the element that we want to set metadata for. So in this case, we want to talk about identifier value. But then now that we're at identifier value, we want to say we're not like setting we're not setting the value itself directly, but we're setting metadata about the value. And that's what we use that little caret symbol for. The caret symbol, or the escape syntax, allows us to actually pop up from the element into metadata about that element. And that metadata is actually defined in something called element definition. So if the entire profile is in the structure definition, each element in the profile, so each one of these fields you see, is represented by an element definition. And I've included a few fields from element definition in this slide. Hopefully you can see those. It might be a little small, but you can download the slide deck if you have trouble there. But this lists out all of the elements within element definition that we can reference when we use the escape syntax. Actually, it's a subset. It's not all of them. We can see short there. So essentially what we're saying is with the escape syntax, I want to look at the element definition that defines identifier value, and I want to set something directly on that. And you can also do something similar with elements within the structure definition itself. But that's why this one's a little bit more complex in some ways, because you have to think in multiple dimensions. But once you've done that and you render it, you end up with something here. And you can see we have the value that is unique within the SIP system and US zip codes shown here. So awesome. We're finally at step 12, finish the profile, brag to friends, because I'm sure all of your friends will be like super impressed that you did this. If you read the exercise, we talked about how there's no better way to start a cocktail party than to, tell people about your exploits with FHIR profiling. People just love stories about that. Like I know my friends and family do. So you should really be proud of yourself. And hopefully you can finish the profile and achieve superstar status. So if you want to do that, you're creating a US core race extension, ethnicity extension, associated value sets that use that advanced syntax. Invariants, there's like lots of complicated stuff here. So what we're going to do, Shorty's got a question for me. Hey, Chris, do you have some nice slides that walk us through all the extra complicated stuff in step 12? Go fish. Okay. I can't hear all of you laugh, but I'm sure you're laughing because you remember that game, Go Fish. And didn't Go Fish, like you ask somebody if they have something, and if they don't have it, they say, go fish. Yeah, I don't have any complicated slides about all the stuff in step 12. You're on your own, but hopefully you can figure it out from here with the help of the specification. And also, you can go ahead and download the complete solution at the URL here. And that has everything, including those complicated bits from step 12. So that's it. We have 1 minute to spare. Do we have any 1 minute questions, Brian?
There is one here that maybe you could quickly answer. Some time ago, our work trying to make an IG with HL7 tooling was impossible because we couldn't get it to point at the developing resources, for instance, in the R5 build. Does FHIR overcome this problem?
Okay, so for that specific question, FHIR Shorthand is defined so that it should work with multiple versions of FHIR. However, the Sushi reference implementation only works with FHIR R4. We haven't yet explored all the implications of supporting other versions, especially versions that are in progress. However, you can reference versions of other implementation guides as dependencies that are in progress. So we know that that does work, and we can provide more information about that offline.
Thanks.
You're welcome. Well, thank you, everybody. Hopefully that wasn't too fast, and I apologize for all those extra weird yellow annotations.
Actually, it made it a little bit interesting, I think, Chris.
Oh, good.
It was funny. So this is Melinda Stewart again from HL7, your host. I just want to take a moment and thank Brian Keeney, our moderator in HUVA. Thank you so much, Brian, for reading those questions for us. Chris Moesel, you did a fantastic job. You even brought some humor into it. We really enjoyed this. And Mark Kramer, we know you're in the background too. Thank you guys from MITRE for presenting today. We hope you have a great rest of the day. Thanks everyone for joining.
Thank you.